In the previous videos, we have discussed quite a detail regarding the methodology of a research study. So far, we have covered quite a number of aspects from the planning of the research in terms of the overall structures, the process of the research, the planning to collect the data, planning for the variables, planning to do the analysis, as well as planning for the schedule of your works. Several examples in terms of the specifications of all the tests, materials, specimens, preparations of the test specimens, test setup has been presented. It is very dependent on your research method, which you need to provide details, specifications, and evidence that you have conducted the respective study and research. There is one important thing you need to know about your research design. First, the purpose of conducting a research. It is to venture into the regions which you do not know. The ultimate goal here is for you to contribute knowledge to the gap of the knowledge so that the research community gain a better understanding regarding the topic that you are studying. Because of the nature of the research, the motivations to carry out a research is actually on basis of wanting to know something that it is not known yet. The researchers are actually venturing into the unknown region. Therefore, normally the research study do not have the standard answer readily available to cross-check whether the research output as acquired from the research is correct or not. It will be very much dependent on how rigorous the research is carried out and how close your research outcome to reflect the actual scenario. That means that throughout the history, whichever theories or concepts being proposed by the previous researcher, it may not be fully true. It only represents the level of understanding the research community managed to acquire at that particular instance based on the technology available then. Therefore, you can consider that a research study is basically an investigation which is putting the missing pieces together in order to explain something which is unknown. There will be testing program. Those testing programs will involve some measurements, putting at several critical places which are properly designed so that with the minimum effort, gain a broader overview of what is actually happening, and then try to tell the storyline to connect all the observations or measured outcome as an effort to explain something. And these explanations will be considered as the findings from that particular research. You know that measurements is very much dependent on where you're going to position it, how extensive that you're going to measure it, how reliable is the measurement, and so on so forth, which can only give you partial of the entire picture. And then you are putting those pieces together, trying to explain something. You can take this as an example. Let's say now these are your measured outcome. You measure an animal. You know that that is an animal because you see it moving. You hear the sound. You hear the animal breathing, and so on and so forth. You know that you want to study an animal, but you do not know how the animal looks like. Therefore, you will use some measurement tools for you, such as using rulers, using your sensory, touching, or pointing spotlight in the dark, looking at parts of the animals. And then these are your measured outcome. Based on all these measured outcome, you try to imagine that how does the animal looks like. Then you will refer to the literature review. You know that the head's going to be in front. The animal probably have 4 legs. The back should be on top. The legs should be at the bottom. The tail should be at the back. There should be eyes. There should be ears. There should be nose. Now, based on the information that you obtain from the literature review, you're going to speculate the locations of different parts. Now you put those parts together and then refer again from the literature review, making conclusions that this animal is actually a rhino, as it fulfills all the characteristics described in the literature review, where parts of the characteristic you obtain from Author 1, the others you obtain from Author 2. This is what it meant by the critical review, putting the things together for you to have a better picture of what it is. In fact, in the actual situations, is it really a rhino? If you look carefully of all this, there could be slight differences in terms of the typical characteristics of a rhino, which to the current stage of the technology, you can open the spotlight for once and it only shows a very little part of the animal that you are studying. You might not be able to accurately differentiate the critical characteristic of a rhino. And then later, with the development of the technology, as well as when the research community gain more understanding of the animal, they realize that it is actually an elephant. The parts that you are measuring, in fact, were actually the ears, the eyes, the horn, the trunk, the feet, and the tail, which is actually an elephant. Now, the more you understand the animal, then you gain a bigger picture and having better comprehensions as well as more refined descriptions of that particular animal. And for the researcher in future, the researcher will be able to differentiate an elephant and a rhino based on certain critical differences, which are the unique characteristics of a rhino and elephant. This is basically a metaphor to describe a typical research, which gives us some lesson that the measurement itself provides informations which reflect parts of the facts. You might not see it clearly here because all the while we have been talking about rhino and elephant. Maybe let us look into this example that you want to do a testing. You want to study the behavior of a reinforced concrete beam. There will be measurements, which they're going to be a load cell, and there are 3 displacement transducers to measure the displacement. The load cell here is used to measure the loads acting onto the member, which is later being divided into 2 loads. That we assume that both vertical load here it will be equal. Now the question is it really equal? And then you have 3 displacement transducers here, 1 at the midspan, 2 just below the point load acting onto the beam. The measurement here cannot measure the deflection of the beam. It is actually measure the vertical displacement or vertical movement of the beam at that particular point. It is for you to interpret this vertical displacement into the actual deflections of the beam. You will need to find the correlations between the vertical displacement as measured from the instrument in reference to the distance from the support in order to acquire the deflection profile of the beam at different stages of the loads. And then the simulated conditions is simply supported beam. Let's say now you found your design is okay, it is strong enough, but your testing only meant for a specific effective length. Is it going to be the same when your effective length become longer? Or is it going to be the same when the beam is actually continuous member and your simulated load is 2-point load with 2 supports? Your testing can only simulate 2-point load. In this case, you do not know that whether the uniform distributed load or triangle distributed load may be applicable for this test specimen. And then you can have a camera to snapshot the crack patterns on the surface of the beam. You can only see the surface of the beam. How do you know what's happening inside the beam? Any movement between the polystyrene and the concrete? What's happening to the reinforcement bar? Even the crack, you only see on the surface. Is there any cracking within the member? Or how deep is the crack in the member? Based on the failure mode, specifically, you are observing the critical crack and you assume the failure mode of the member. Is it really the failure mode as what you have perceived? And then based on the crack pattern, probably measurements given by the strain gauge, you will assume the stress developed within the member. On basis of some prior understanding, maybe you can suspect where are the highest stress region. Is it actually true? Nobody knows. Therefore, when we need to study something, we try to do measurements at the critical area, covering as many aspects as we could. And if we are able to tell a storyline, logically link all the aspects being covered in line with what you have observed and measured, we assume that the relevant principles, theories, or concepts should be true. Now, is it really true? Nobody knows. But we know that at least it is close to the truth. Probably we are able to grab at least 80% of what is actually happening, and that 20% is probably due to our bias in terms of the interpretations, or our measurement programs are unable to identify that. This one we have to leave it to the following researcher to proceed the study. This is what I mean with the measurement itself only provide informations which reflect parts of the facts, but it may not be fully true. It is through the compilations, analysis, interpretations, synthesis, in order for you to conclude the findings. You are actually trying to describe a subject study which might not be fully accurate. Therefore, measurement needs to be carefully designed to be critical, accurate, and adequate to describe the subject that you study in order to prevent misleading results or inaccurate findings. Then you might want to ask, why is this relevant to you? Or why do we need to discuss this? First, you need to know the limitations of the measurements. You need to know that the measurements is actually reflecting parts of the truth. The rest of it will be based on your interpretations as an outcome of the synthesis of your prior knowledge on the subjects that you are studying. Second, knowing these limitations, you really need to properly design your measurement programs. What kind of measurements you want to do? Where do you want to measure? What is the purpose of doing those measurements? There must be a reason for that. You don't want to miss the critical measurements that allowing you to be able to explicitly differentiate the actual situations from your assumptions. You will need to ask yourself, how do you want to address this in your research design? Think about it. This gives you a message. There is no one perfect research. Even though the work is carried out by you, you feel you have gained a lot of understanding. You are very proud of yourself, managed to get through your postgraduate program, acquiring your PhDs. You will still need to stay humble It only proves that you are one step closer to the actual situations, but you may not 100% fully understand these situations. It is a lifelong learning to you.